find the limit if it exists. Again, we're doing this analytically. Step number 1, evaluate a limit. It's just plug in our number, our x value of 4 here, limit as x approaches 4 of the square root of x plus 5 minus 3, all of this divided by x minus 4. So if I directly substitute in, I get the square root of 4 plus 5, which is 9, minus 3 over 4 minus 4. Square root of 9 is 3. 3 minus 3 gives us a 0 over a 0, which is an indeterminate form. So then we're going to try to fix it. This one has square roots in it, so we're going to try to fix it by rationalizing the numerator, wherever the heck the square roots are. Try to get it from the top and put it down in the bottom. And we do that by multiplying by a conjugate. So the limit as x approaches 4, I'll just rewrite the problem here, x plus 5 minus 3 over x minus 4. And we're just going to take the conjugate of this top part here, multiply it on the top and the bottom. So the square root of x plus 5 plus 3 over the same thing. So in other words, we just multiplied it by a fancy 1 right there. And so we're not going to change our function, we're just going to change the way it looks, essentially. Okay, so now across the top, let me bring my limit back here. Limit as x approaches 4. Across the top, it's like the difference of two squares, so we only have to worry about the first terms and the last terms. So it's x plus 5 squared, which is just x plus 5. And then negative 3 times positive 3 makes this a negative 9 over, and then on the bottom we're just going to keep it factored, so I'll put the x minus 4 in parentheses, and then the other bit that we just multiplied by we'll put it instead of parentheses too. So the square root of x plus 5 plus 3 still in parentheses. Okay, so across the top this will simplify to x minus 4, which, oh, would you look at that, how did this happen? They have a common factor, so I'll cancel those things out, divide them out, leaving with 1 up top. Let's rewrite our limit. Clean this up a little bit as x approaches 4 of 1 over the square root of x plus 5 plus 3. Okay, so this function that we just generated is identical to the original one over some sort of interval, except for at 4, which means that all I have to do is just plug in 4. Like the original one has a hole in it, but my new one does not have the hole at 4. So we can figure out what its function value should be at 4. So we'll just directly substitute this in here. We got 1 over the square root of, we have 4 plus 5, it's going to be 9, plus 3, that's a 3 plus 3, which is 1/6.